Hi, this is Math 1650, and this video is over section 2.1. And we'll start looking at data and how we start to analyze the data. So first we'll start with some definitions here. When it comes to a data set overall, and so maybe you have 20 data points or 30 data points, a couple of things we really look at. We look at the center of the data. So the center, these are measures of the central point or typical values in the data. Okay. One may be the average, which we call mean, but there's also the median, the mode, and the mid-range that we'll look at. Then we also look at the variation. This is measures of the extent to which the data differs from the central values. So a large variation, so maybe the average is 15 and the variation goes anywhere from negative 150 to positive 150, or maybe the average is 15 and the variation goes from 10 to 20. And then distribution describes both of these features and how the data values are spread across some range. We can think of it as the overall shape. Okay, and we'll see a couple distributions. There's the normal distribution, which looks like a bell curve. So it starts out low, gets really high, goes back to low. There may be a uniform distribution where it kind of stays leveled. Every possible value is at the same point. You can have a skewed distribution where it starts out really high, gets really low. And this would be a right tail, or right skewed. Or it could be opposite. It could start really low, get really high on the left side. This is left skewed. You know which way it's skewed based on the tail. The tail's on the side that we will call it. Right. And so we start out looking at what's called a frequency distribution. This is a list of values individually or grouped. If we have a lot of values, we start to usually group them. And their counts or frequency. Same thing. Okay. So this graph or table is the distribution of items sold at a garage sale, including the relative frequency. We'll get into what the relative frequency is soon. The frequency for this, so we have this in classes. Class 1 is $1 to $5. That means 8 items were sold anywhere from $1 to $5. Class 2, $6 to $10. They had 6 items sold somewhere in that range. class 3, $11 to $15. That was 4 items sold. 2 items were sold at $16 to $20. That's class 4. 4 items were also sold at $21 to $25. That's class 5. Class 6, $26 to $30. 6 items sold. In class 7, $31 to $35, and there was only 2 items sold. Now, with this, the lower class limit. Okay, we're going to be looking at this column here. These are the lower values in each class. So 1, 6, 11, 16, 21, 26, and 31. Okay, that's this side. Upper class limit 5, 10, 15, 20, 25, 30, 35. That's this side. That goes from your lower to your upper class limit. Okay. Class boundaries. These are where you have the boundary between the two classes with no gaps. So you basically look at the upper and the lower and you go right in between. So 5 and 6 right in between will be 5.5, and then 10 and 11 will be 10.5, 15 16 will be 15.5, then 20.5, then 25.5, and 30.5. Now we also do the outsides of both of these, so we'll do 35.5 and then go back to this halfway down of $1 will be 0.5. Right. Class midpoints is you take the upper and lower limits for each class. I'm going to do the first one, you find the average. So 1 plus 5 is 6 over 2. Oops, 6 over 2. I'm thinking the answer here. 6 over 2, which is 3. Okay, so your midpoints are 3, 8, 13, 18, 23, 28, 33. Now, all of these, and this last one I actually used what I'm going to say next to get all those without having to do the math in my head. All of these, notice the differences between these numbers are 5 every time. Okay, as you go all the way through. Same thing with the midpoint. Okay, so the difference between those numbers are the same, and this is a class width. So class width is the difference in class boundaries, midpoints, limits. In this case, it's equal to 5. I'll make that 5 look like more like a 5. There we go. All right. So low class limits, lowest number in the class. Upper class limit, highest number in the class. Class boundary is the difference between one class to the next, including the end. Class midpoint is the average of the lower and upper class, or the midpoint of that class. And then class width will separate one class from the next in all those categories. Alright, so with constructing a frequency distribution from a set of data, and here we have a set of data. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6. So that's 66. 7, 8, 9, 10. That's 70. 1, 2, 3, 4, 5, 6. 76 total. These are ages, 76 total ages. Ages of best actresses. We want to decide how many classes we want to choose. Usually it's anywhere from 5 to 20 when you have a decent amount of set of data. Two main classes, and maybe you don't have enough data values in each of the classes. Two little classes, and it just looks like one big class, or a couple of just big classes. So we're going to choose 6 here. 6 will be good. You're looking at about 12 or so data points per class. Then we gotta find the class width. So we're going to look at the minimum value here, which is 21. It may happen a couple times, but that's where it is, at least once. And the highest number is 80. So that's your max and your min. We're going to subtract these and divide by the number of classes we choose. And there's kind of like a, adjustment we may make when we do this. So 80 minus 61 is, or 80 minus 21 is 59 over 6 is 9.83. So we're going to round up to 10. 10 is going to be our class width. So, if 6 is giving us 10, close to 10, we're going to want to go with it. If we would have chose 5 in this case, we're looking at about 11. We may want to think about, well, let's add one more class and make this go up to 6 so we can get it down to a nice round number. So now once you find your class width, you may go back and decide maybe you add or subtract a class. Then you want to choose a convenient starting point. Usually it's either the lowest number, or maybe we choose 20, but I'm going to go with 21. And that's going to be the lowest. And then we add the class width and get all the lowest class limits. So width is 10, so 31, 41, 51, 61, 71. And then we get the upper limits by going one below that, below the next lowest limit. So 21 to 30, 31 to 40, 41 to 50, 60, 70, and 80. And all those limits should also be a difference of 10. Now we have the classes, we have them spaced out. We have 6 classes. All the numbers are going to fit in one of these classes, and so we have to start totaling everything. So I'm not going to go through and total it. You can if you want to. I'll just tell you what I have found. There are 28 between 21 and 30 years. There's 30 between 31 and 40 years. There's 12 between 41 and 50 years. There's 2 in the next 3 classes. So first thing is sum of the frequencies. This is the total number of data values. It's important to know because it comes into how we find our relative frequency. That's total 76. Okay. Before we do the relative frequency, let's look at the cumulative frequency because it's easier. This is the sum of the frequencies for that class and previous classes. So it's basically a running total. It's also one way you're going to do find the sum of your frequencies. So we start out with 28, then we add 30, so we got 58. Then we add 12, so we got 70. Then we add 2, so we got 72, 74, and 76. The last frequency, cumulative frequency, should be the total amount of frequencies, or total amount of data values. Right, now we have to find the relative frequency. This is the class frequency over the total frequency. So in this case, everything's going to be out of 76. So 28 over 76, 30 over 76, 12 over 76, 2 over 76 for the next 3. That's the fraction. And if you notice, the fraction is going to add up to where you have 76 out of 76. That should always be the case. Then we're going to find percentages. So first one is 36.8%. And then 30 divided by 76 is 39.5%. Divided by 76 is 15.8%. And 2 divided by 76 is 2.6%. Now there may be a little bit of rounding that gets this off, but it should be really close to 100% when you add them up. You get 99.9%. Okay, so it is 100%, just the rounding there. I rounded probably the last 3 lower, so it's a little bit less. But that's how you do your relative frequency. So we're going to look at another data set. This is with the IQ scores. We're going to find the relative frequency. We're going to find the cumulative. Right, so frequency for 75 to 79 is 4. Then we add 5 to get to 9. Then we add 6 to get to 15. Then we're adding 2 to get to 17, 18, 21. So total here is 21. Relative frequency would take each one out of 21. So 4 out of 21, 5 out of 21, 6 out of 21, 2 out of 21, 1 out of 21, 3 out of 21. So we can find the percentages here. 4 divided by 21 is 19.0%. 5 divided by 21 is 23.8%. 6 divided by 21 is 28.6%. 2 divided by 21, 9.5%. 1 divided by 21, 4.8%. And 3 divided by 21 is 14.3%. We add these up. We get exactly 100%. Okay, so now let's look at lowest class limits. 75, 80, 85, 90, 95, 100. Upper class limits start with 79, 84, 89, 94, 99, 104. Class boundaries. Again, we start right below the 75, and we know its class width is 5, so we'll add 5 each time. So 74.5, 79.5, 84.5, 89.5, 94.5, 99.5, and 104.5. Midpoints, we're going to average the first two, so 79 plus 75 plus 79 over 2. And you get 77. And then we'll add 5 each time. 82, 87, 92, 97, 102. So class width is 5. And we found the relative and commutative frequencies for each class already. Alright, that is the end of section 2.1. In 2.2, we'll start looking at histograms. I'll see you then.